Welcome to another episode of Dinosaur Parkour. The topic for this video is IMS, position equal M, the power of multiple positioning. I'm your host, Chris P. Fried. Position equal M is coded into PSB to tell IMS to maintain a position on each hurricane leg, which allowed for more intuitive coding of IMS calls. Programmers can access the segment in an order that makes sense, rather than being forced by a single position into accessing the segment left to right. A programmer can read a child on the right side of the route and then read a child on the left side. Position equal M is the default for FastPath data entry databases. If a FastPath PCB has two or more hurricane legs, the position equal M is assumed or enforced to be true even if position equal S is coded in the source. This is an example program communication block for the hospital database shipped with IMS by IBM to assist in the validation of the installs of IMS releases. I added the item and cost segment to this PCB so that there would be two hurricane legs for the PCB. For the purpose of this example, the hospital DBD is a full function HDAM database. The position equal M keyword value pair was added to the PCB level. That tells IMS that we want IMS to track positions at each hurricane leg. So the hospital plus the ward plus the patient is a leg. The hospital segment plus the item segment plus the cost segment is the other leg. There's a wee bit of extra overhead for IMS to track the multiple positioning, but my experience is that programmers are able to write much tighter I/O logic and use more get next within parent calls, which use less CPU than a get unique call. So the overall result is a minor savings since fewer expensive IMS calls are used. This chart shows how multiple positioning behaves versus single positioning. Here's a disclaimer. I do not have access to a ZOS instance with IMS installed, therefore I'm unable to test what I'm saying. I'm doing this from memory, and I believe that the information that I'm providing is correct. So the box labeled R1 is the root segment. It has three children segments under it, segments A, B, and C. And segments A and C have two instances. And for the purpose of this slide, segment D, E, and F do not factor into the results. The first IMS call is a get unique for segment R, where the root key is equal to 1. Single position and multiple position, the R1 segment is red. Position is on the root and parent is on the root. Call number 2. Get next within parent requesting a child segment A. There's no qualification on A, so the first A found after the current position is returned. A1 is returned for the single position and the multiple positioning. Parent remains on the root, R1. Position is on the segment A1. Call number 3. Get next within parent requesting child C. IMS returns C1 for both the single and the multiple positioning. Parent remains on the root, R1, and position is a tad more interesting. The current position is C1 for both the single and the multiple positioning, denoted by the asterisk. For the PCB that's coded as multiple positioning, IMS remembers the positioning on the segment A1. It's just not the current position. If the PCB has single position, there's only one position, and it's on C1. Call number 4. Ask for another child's A segment. Get next within parent A. Single positioning failed. This is how IMS basically thinks. I can only go forward when there's not a child A in front of my single positioning. There were some child A segments, but those segments are behind my single positioning. That means GE, or segment not found. Another A segment might exist, but I'm not allowed to go look. For the single position PCB, position remains on C1. However, it is no longer considered current, meaning that it cannot be replaced. The multiple positioning PCB has positions on two hierarchical legs. The current position is now on the A2 of the R-A leg. On the R-C leg, a position remains on the C1 segment. Call number 5. Get net within parent for segment C. Both the single and the multiple positioning PCBs return the C2 segment. Current position is now on C2 for both, and parent remains on the root R1. Call number 6. Get net within parent for segment C. IMS does not return data for either call. A status code of GE was returned for both the single and the multiple positioning call. Position for both single and multiple position is where the missing C segment would have been had it existed. Call number 7. Get net within parent B equal 1 in 2. IMS starts tracking the position on the third hierarchical leg for the multiple positioning PCB. The current position is B1 for this PCB. The single position PCB returns GE because the B segments are on a hierarchical leg prior to the C segment. So the position remains where the missing C segment would have been. Focus on the multiple positioning PCB for a bit. When I started to learn IMS, I was told that Get Unique destroys parentage in all previous conditions. After a successful Get Unique call, the parentage is recreated and only a single hierarchical leg is being tracked. So let's do a couple of calls to determine if this is true. Call number 8 is to Get Unique for the segment F. However, the call is qualified at all 3 levels in the hierarchy. If you look at the slide, it should be clear what I mean. We asked IMS to return the data for segment F, and we told IMS to keep the parentage on the root. There's an implied first at each level when a Get Unique is new. The way to read the call is bottom to top. Remember, there's an implied first at each hierarchical leg, and you read from bottom to top. Starting with the first F segment, return the data for the first one, because there's no qualification. We want an F segment that is under the first segment B with a key of 1. So IMS starts with the first B segment and finds the one that matches the SSA B equals 1, and we want that to be under a root segment of R with a key of 1. After the call complete, the position is on F1 for the RBF leg. The position on the RBF leg was changed and is now the current position. However, the position on the RA leg remains on A2, and the position on the RC leg remains where the missing third C segment would have been. So the answer to the question, does Get Unique reset position, is no, at least for now. Call 9. Get Unique R1 equal to 1 in 2. Since the non-hierarchical read of the root was done, all existing positions are reset for this PCB. Or to word it another way, since only the root is read with this Get Unique call, all prior positions were cleared and the one current position is now on the root segment. The parent is just on the root segment, and the one and only position is on R1 until subsequent get next within parent calls are done. So the correct way to say that a get unique resets all positions is a non-hierarchical get unique for just a root segment resets all positions for the PCB.